Hello everyone. So, free energy, hoax or true? That's a question I was trying to find an answer to since 2008, I think. For a few months, uh, I didn't know that it's considered to be a hoax, and that's scientifically unacceptable uh, to even try to find methods to get free energy. So, I've, despite knowing that fact, I didn't stop trying to find new methods to bring free energy. I thought of it as a puzzle, the impossible puzzle that I tried to solve. Uh, During these attempts, I learned a lot of things about physics, and it was really useful and educating. So today, I hope you look to what I have to say and look to it as a puzzle, not as a challenge, not not as I'm trying to break any laws or rules. It's all within the laws of physics. So I myself debunked many designs for free energy, including my own designs. I make a design, I try to modify it, make it better, then I go into the calculations phase and I realize the output is going to be zero. So I try to look without any bias to any design that I have, and I rarely that I publish anything like this on YouTube or online in some forums, unless I cannot find why it wouldn't work. And honestly, I did that maybe once or twice before, and I discovered why it doesn't work. Some people helped me. So today I hope you help me and tell me why this design that I'm going to show you is useless and cannot produce free energy. So let's go to the next slide. Uh, this device, I think we can call it the gravity controlled buoyancy. But first, let's have a look at the first slide. This here we have, yeah, I know it looks like the perpetual motion, the notorious perpetual motion and the hoax of free energy, but yeah, cut me some slack. Uh, this perpetual, sorry, these 8 arms of pistons, these are pistons here at the end of each arm. It's laying flat horizontally in this position just to show you something. These pistons are tight, like the air cannot go out or in these cylinders. There's a mass in each connected to each piston that guarantees that the center of cavity of this cavity coincides with the center of gravity of the piston and is along this arm. So, for example, this piston could be virtually weighing zero, uh, but I put here the CG, or I put some mass here, and this is actually the case in right here. You see a mass just hanging here connected to the piston, and this mass is the weight of this mass um, equals the weight of water if to fill this cavity. So if this cavity is 1 liter, this weight is 1 kilogram. Now, this is the first position. When it's horizontal, they all look the same. Now, if we try to make it stand up, make it upright, this will be the situation here. Don't know if you noticed this or not. I cannot go back in the slide, but this one fell down a little bit, and this one fell down a little bit because of gravity. So here we have a little bit of negative pressure, not negative pressure, but less than the atmospheric pressure. And here also uh, a little bit more pressure than the atmospheric pressure. Now, if we submerge this group, this wheel in water, uh, water pressure is going to have a big role. Not on this one, no, But in this one, and the lower we go, the more effect of the water pressure we're going to have. So, and this, what's going to happen, please pay attention to this one and this one, as I cannot go back in the slide to show you what's going to happen. 1, 2, 3. So the water pressure compressed this a little bit and compressed this a little bit. So now you can see that we have almost even distribution of the masses along the wheel, but visually and apparently not even distribution of cavity, and thus not even distribution of buoyancy force. As I display here, the arrows, the red arrows are the weight vector, and the yellow one is the buoyancy vector. Uh, so you can see here that this one is bigger than this one, and so there will be more upward force in this side than this side. And now, of course, this is just a diagram to show the idea, but there will be some calculations. But first of all, now you see me that this is the second step. I'm I'm relatively aware of what's going on when we play with mechanics and water and water pressure and atmospheric pressure and these things. So I try to pay attention to every detail, including like for example this one here. Let's take it into zoom in view. Now, because this one, there's a component of the weight that expanded the cylinder or the piston a little bit, and that made the center of gravity shift from the center of buoyancy. It went to that direction, and that's why they're not on the same line anymore, and that creates torque. And for each arm there will be different torque. Sometimes it will be to the right, sometimes it will be to the left, sometimes big, sometimes small, but I took this into consideration. Now we go to the next slide. It's just an image of a spreadsheet, not the whole thing. Just trying to show here that I made this calculation and I put in the last two columns you see here. The red is to one direction, the blue is to another direction or the opposite direction. I have here the CG torque. This is the torque that I just showed you, resulting from the shifts between the center of gravity and the center of buoyancy. And it's, I don't want to say it's insignificant, but as you see, it's almost insignificant. And the mass minus volume torque, the result that come from the difference between the mass and the volume for each cylinder. The first thing I used here, the start point is the atmospheric pressure above the water surface. I'm sorry, it's not in kilogram centimeter. This one is meant to be tons per square meters. And then the wheel arm, the mass that I put in the piston. What is this? The free volume, that's the volume of the cavity, the area of the piston, and of course the piston L is like the distance, the depth of the cylinder. So and here the arm angle, I presumed 36 arms with 10 degrees separation, and took the calculation for each arm, how it's going to be, and finally it gave me a net torque of 9.5 Newton per meter square. That's for a wheel that is 6 meters of diameter. Now that's very small, I know, but there's ways to make it more by playing with the atmospheric pressure and the length, the length of the arm and the area of the piston. There's a lot of things that we can manipulate here to get the biggest torque for the smallest volume and the least overall mass. So that's it. That's the whole idea. Um, if you don't have to do these calculations or to prove me wrong, just let me know. Well, of course you can repeat it, but what I'm trying to say, if you find any point that I missed, I didn't take it into account, and I didn't make the calculations for, just please point to it. And same as I did with the center of gravity shift torque, I'll put it into consideration, and I'll calculate it. And of course, if you can do this spreadsheet or whatever method you have to inspect the efficiency or the feasibility of this device, please do it, and I'll be glad to watch it if it proves that this thing is not going to work. Now, thank you all for watching so far, and I really hope that you can look into it and tell me why it wouldn't work. Thank you.